Okay, today we're going to talk about scientific notation. So first, what exactly is this? If you go to your calculators and you type in the number 5 million and you multiply that by 4,900,000, you're going to get an answer that looks like that. I think you've seen that show up a couple times in your calculator. What is that? That is actually an example of scientific notation. Scientific notation is something that we use to express really big or really small numbers. So we use scientific notation to express very large or very small numbers. For instance, let's say that you have an example that says the population of China is greater than, 100,000, 1,250,000,000 people. This particular number is not really that bad to read or to see or do anything like that, but what if I asked you to multiply that by 640,000? Your calculator is not going to be able to handle it. If you try to do it by hand, it's going to be incredibly challenging to do, take a long time, and it's really not worth your time. So we have this thing called scientific notation where we can write this in a much smaller and easier way to make the numbers easier to handle. So what we're going to do is we're going to create a number that has only one digit before the decimal. So if I consider all of these numbers, right now the decimal here is all the way at the end because this is a whole number. I'm actually going to move the decimal so that there's only one digit before the decimal. So I'm going to put it right here. So what I'm going to do now is write this down as 1.25, and I'm going to stop as soon as I have no more digits other than 0. Okay, so here is going to be my number, the beginning of my number in scientific notation. But now what I really have to do is look at the idea that this decimal is 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces away from where it originally belonged. Okay, so there's 9 spaces. And the way that I can actually move the decimal mathematically is to multiply by a power of 10. So when I take 1.25 and I multiply it by 10 to a power, that's what gives me that larger number and how I can write it in different ways. In this case, what power would it be? It would be the 9, the number of spaces that we move. 1,250,000,000 is equivalent to 1.25 times 10 to the 9th power. We can write very large numbers in a more concise and manageable way. Okay? So, what about a very small number? Let's say I have the diameter of an electron is that thing. I really don't want to have to read that, and I don't expect you to have to read that. So I'm going to use the same process that I just did on the last example. I'm going to create a number where I've got one digit before the decimal. So if I take a look at all these things, the only place that makes sense to put the decimal is going to be right here. So I'm really going to have 1.1. Now, how many times did I move the decimal to get there? This one would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There were 12 spaces. Notice that this original number is smaller than 1. The whole number, the entire thing here is a decimal. And thinking about the exponents unit from before, negative exponents result in fractions or decimals. So in this example, I'm still going to multiply by 10, but now 12 is the number of spaces I move, but since I'm creating a number smaller than 1, I'm going to multiply this by negative 12, raise it to the negative 12th power. So my number here for the diameter of an electron, is 1.1 times 10 to the negative 12th centimeters. This is called standard form. This is called scientific notation. Okay? Let's give a couple more examples, and then we'll look at what does all this really mean? How do we concisely determine what to do here? Okay? So, at an election in India, more than 343,350,000 people voted. You know, that's just it's a cumbersome number, so we want to write that in a more concise way. So I'm going to place a decimal. Right now the decimal is right here. I'm going to place it somewhere where there's only one digit before the decimal. The only place to do that is going to be right here. Okay, so now I'm going to write this down, write all my non-zero digits. So this would be 3.4335. And then I drop the rest of the non-zero digits. Okay? Then I count how many spaces from here to where the decimal originally was. This is going to be 1, 2, 3, 4, 5, 6, 7, 8. It was 8 spaces. My original number is a whole number larger than 1, so I'm going to have 3.4335 times 10 to the 8th power. The 8 is going to be positive because I have a whole number. Okay? See if you can try this one. A Saudi Arabia oil field contains about 82 billion barrels. What would that look like in scientific notation? See if you can pause the video and try that out. Okay, so I'm going to put the decimal right between the 8 and the 2. So I really have 8.2. How many spaces? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be times 10 to the 10th power because I had 10 spaces. The original number is larger than 1, so my exponent is positive. Okay? One more. A microbe strain of H39 has a diameter of 0.000 bunch of zeros 3 meters. Write that in scientific notation. Try it on your own. I need to put the decimal so there's one non-zero digit before it. So the only place I can't put it here because then 0 would be before. So I have to put the decimal here. So I'm actually going to have 3 as my number. It is 1, 2, 3, 4, 5, 6, 7 spots. 7 spaces. And again, this number, the original number, is smaller than 1, so I'm going to make the 7 negative, so it's 3 times 10 to the negative 7th power. Okay? So what we are really looking at doing here, scientific notation has a very specific format. Scientific notation is going to have a number multiplied by 10 to some exponent. This number right here, I'm going to call that the coefficient, has to be larger than 1, but smaller than 10. Actually, it can be equal to 1. So larger than or equal to 1 and smaller than 10. And the exponent here, there's no restriction on what the exponent can be, but this represents the number of spaces that we're moving the decimal. Okay? So there's our general idea for what scientific notation actually is. So the other thing we have to be able to do, all the examples that we just did, I started with a number in standard form and I changed it to scientific notation so that it was more easily manageable. Now we have to be able to go backwards. So let's say that I tell you that the wavelength of an X-ray is about 1.5 times 10 to the negative 9th meters. The first thing that I'm going to do is I'm going to recognize that this right here is a negative exponent. That means that my number in standard form is going to be a decimal, smaller than 1. Also, think about a number line and the fact that negative numbers are to the left of 0. So in order to change this into standard form, I'm going to write my 1.5, and I'm going to realize that the negative 9 tells me that we're going to move to the left 9 spaces. Move left 9 spaces. Okay, so I take my 1.5 and I put my pen right on that decimal and I carefully count 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, put a new decimal point. These spaces have to be filled in with zeros, so there's all these zeros that go there. So in standard form, please rewrite this, don't leave that as your answer. In standard form, I'm going to have 0.00000000015. That is the number in standard form. Okay? Now we take a look here. In 1996, the U.S. national debt was 5.129 times 10 to the 12th dollars. I want to change that into standard form so I can have an idea of how much money that really is. I'm going to realize that 12 right there is positive. Positive numbers are to the right of 0 on the number line, so this tells me that I'm going to move right 12 spaces. So I am going to start with my 5.129, and I'm going to move that decimal point right 12 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and put my new decimal point. Fill in the empty spots with zeros. And again, we're going to rewrite this. Don't want to see that mess as an answer. So I have 0, 0, 0, 0, 0, 0, 0, 0, 0, 9, 2, 1 with a 5. Okay? 100,000 million billion, $5,129 billion in debt. Okay? So once again, positive exponent means that I have a whole number larger than 1. Negative exponent means that I have a decimal smaller than 1. Okay? So see if you could please try convert. The fastest planet, Mercury, travels at 1.07 times 10 to the 7th miles per hour. Pause the video and change that to standard form. So this would be 1.07. I'm going to move to the right 7 times. So I'm going to go 1, 2, 3, 4, 5, 6, 7. And there's my decimal. Rewrite this as 1, 2, 3 zeros, 1, 2, 7, 10. Okay. Next, the diameter of a virus is 2.0 times 10 to the negative 7th meters. That's a negative number, so I move left. So I'm going to do 2.0. I'm going to go 1, 2, 3, 4, 5, 6, 7 spaces to the left. Fill in my zeros and rewrite. 1, 2, 3, 1, 2, 3, 2, 0. Okay. Last one. A rectangle has an area of 3.5 times 10 to the negative 5th centimeters. Again, that's negative, so I move to the left. So I'm going to have 3.5, 1, 2, 3, 4, 5. Fill in the zeros. So I have 0.000035. Okay? This will also allow us to compare numbers, very large and very small, and to eventually perform operations. Please be ready for questions, and we will take this a little bit further in class. Enjoy your long weekend.